Okay, so this should hopefully be a shorter video, but I'm just talking about limits that go to infinity. So this would be if, x is going to infinity. Now, we're going to start off with the method that's just plugging the number in. If you had the limit as x approaches infinity of x, well, which you can't see because of the glare, well, then that would just equal infinity. Just like before, you plug it in. But think about it. If the graph of f of x equaling x looks like this, then as x keeps going on and on to infinity, it's just going to get higher and higher, and it's going to eventually equal infinity, so that should make sense. Um, Now let's remember the rules, though, about the top heavy, bottom heavy. If it's top heavy, so for example, if we have x squared minus 2 over x plus 1, where the highest power on the top, which is x squared, is higher than the highest power on the bottom, then this is going to equal infinity. Because, I think this is a pre-calc thing, but as this one is rising, infinity is being squared, so therefore it's going to rise quicker and quicker and quicker, and it's going to make the denominator insignificant, therefore that equals infinity. Now if it's bottom heavy, well then it equals 0, because if you're thinking x minus 1 over x squared plus 2, the bottom's going to get bigger and bigger and bigger, so you're going to end up getting like 1 over infinity, which in limit terms is, if you believe that infinity exists, then that means this should equal 0. Dividing by the biggest number in the world will give you the smallest number in the world. And if it's the same on the top and bottom in terms of power, so for example, if we get 3x squared plus 2 over x squared minus 1, well, in this case, the leading powers are the same, so it would just be the leading coefficients. So in this case, I think you can see, this would just be 3 because of the leading coefficients. Um, Once again, with these problems, you're going to have to do some reducing a lot of times to get to this, including, and I'm not going to do one right now, but for a problem, because it's very, 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 very messy, but for a problem like this, you would have to actually multiply by the, what's the term? It's like when it's plus instead of minus on the top and bottom, and then it'll eventually cancel out and you'll get a nice thing. But it takes forever to do, and I'm not going to show that to you. My point is, of course, algebra still comes into play here. If it's not in a simple case where the top heavy, bottom heavy, or the same, where you can do leading coefficients, you're going to have to reduce until it gets to that. Or, if you have something like this, over, let's say, x squared plus 3, you're going to have to do L'Hopital's rule, which I'm going to talk about in its own video, like, way later. I think that's unit, like, 4. But that's where you take the derivative of the top and bottom, and then do the limit again. And that's only if you get infinity over infinity, or 0 over 0, which you get infinity over infinity in this case, but we'll talk about that in a later video.